In section 3.4, we're going to be talking about colloids and suspensions and comparing those mixtures to solutions. Colloids and suspensions are special types of solutions. So let's recap solutions. When we have a solution, it is a homogeneous mixture. So it's going to be made from the dissolution of a solute into a solvent. So just to clarify those terms, the solvent is going to be the thing that does the dissolving. And in a lot of cases, water is going to be used as a solvent because water is the universal solvent. Other things like alcohol could be used as a solvent as well. So the solution is going to be mostly made of the solvent. The solute is going to be the thing that gets dissolved, and it's going to be found in lesser amounts in the solution. So things like sugar or salt, those are examples of solutes. Those are things that can get dissolved. The particles in a solution are going to be very small, and in fact, they're going to be too small to be filtered, and they can't be scattered by light either. And that's going to be important in a few minutes when we circle back to the Tyndall Effect. Solutions are going to appear sort of translucent or transparent in color, so they're going to appear sort of clearish, and that's an important distinction for solutions as well. So let's look at suspensions next. Suspensions are going to be a type of heterogeneous mixture, and these are the types of mixtures that are going to separate very easily. If you have a container of orange juice, for example, on the container it's going to say, shake well before use. And the reason why is because if you have pulp in the orange juice, it's going to settle down to the bottom of that container. And so you're going to need to shake that up before you pour that out into a cup or into a glass. The particles in a suspension are going to be larger than those in a solution. And some of those particles are actually over time going to separate and they will settle down to the bottom. A great example of that is a snow globe. So if you have one of these snow globes, you know that the particles will be at the bottom of the snow globe. And then in order to mix them up, you have to turn it over and shake it around. And so all the snow particles will end up falling back down to the ground and settling at the bottom. That's because it's a suspension. And in a suspension, the particles can be filtered as well. So it's generally going to be the materials that can settle down to the bottom. Those are going to be the materials that can get trapped in the filter paper when you're trying to filter that material out and separate it. Suspensions are also going to be sort of cloudy in appearance usually. They're not going to be that nice, transparent, clear sort of color. Colloids are another type of heterogeneous mixture. The particles in a colloid are going to be in between the size of solution particles and suspension particles. So colloids are kind of medium in size. And the particles in a colloid, since they are kind of medium, they are not going to be able to get filtered out. So they are small enough to pass through filters and to not be trapped, but they're not large enough to settle out at the bottom like you would have in a suspension. Colloids are also going to be able to scatter light just like suspensions. So if you were to shine a light or a laser pointer through a suspension or a colloid, then they would scatter light. The materials in a colloid are not going to separate. They're just going to kind of be distributed throughout that material. And they're going to be sort of cloudy in appearance. So they're not going to have that transparent appearance as you would find in a solution. So let's look at these three glasses. So we have a liquid in each of these glasses. We've got salt water, we have milk, we have some hot chocolate. So which one of these is going to be a solution? It's going to be this salt water here. So this is going to be a solution because the salt is dissolved in the water, in this case to make salt water, and is also transparent in appearance. Both of these are cloudy, the milk and the hot chocolate mixture. So we let this hot chocolate sit for a while. What's going to end up happening to some of these chocolate particles within that liquid? They're going to end up settling to the bottom. So that indicates that this is a suspension. And you could let this mixture set over time in order to test that out. And in milk, if you think about a milk container, it does not say check the contents before you use it. In this glass of milk, it's going to be considered a colloid. The Tyndall effect is one important term that describes the properties of how a suspension and a colloid will act. So, the Tyndall effect refers to the ability for colloids and suspensions to scatter light. In a solution, if you were to shine a light or a flashlight, laser pointer through the solution, you would not be able to see the light dispersed in the material. However, if you were to shine that light through a colloid or suspension, you would be able to see the light in there. And that's because you're seeing the light being scattered by those particles. And this is a beautiful illustration of where you may have actually seen this before. If you have a light that's coming through a window, and if that light is sort of filtering through dust particles or smoke particles that may be in the air, then that's an example of the Tyndall effect, producing these rays as that light passes through the air. Smoke particles in air can actually be considered a colloid as well, and that's because those tiny particles are going to be dispersed through the air, and they also can scatter light. That's one interesting way that we can actually see a colloid.